is lesson 9.6, factoring ax squared plus bx plus c. You should be on page 593. I want you to notice this lesson is how to factor a trinomial when the value, the lead coefficient, is something other than 1. In the last lesson, every problem we did, the lead coefficient was 1. We're going to figure out how do you factor these when the lead coefficient isn't 1. This book teaches old school factoring, which is a trial and error process. The problem with the trial and error process is that as A and C become larger numbers, the trial and error process grows, which means it gets to be kind of lengthy. I remember having to do this in high school, and I'm sure if your mom and dad took algebra, they would remember this too. It can be a long, pain trial and error process. For example, a problem like this, this process was really you just sample double distributing until you could figure out the right combination. Okay? I have something better, I think, and I think your parents, if your parents are going to look at what I'm going to show you here and be like, I've never seen it before, have them watch the next 4 or 5 minutes of the video, and I think they would agree after living through the trial and error that this is a better process. Here is a method of factoring these problems, which is not in the book, but I feel it will be easier for you than trial and error method that your parents and I learned. If your parents think this is crazy, have them watch this portion of the video, and I think after the fact they'd agree that this is a better system than what we were taught, which was just trial and error. For the lack of a better name for this, I'm going to call this the Brooklyn method, because I had a student who attended Sylvan, and that person showed me this, and it's pretty cool it works. So take this problem, which is example 1 in the book. Here is what you'd have to do. First of all, you have to make sure, let me take a highlighter, that the A value is positive, which you see here, it is positive right now, and that we factor out any common factors first. Let's check. 2, 7, and 3, there's no common factors there. And each term, these don't all have an x, so I don't have any common factors. So I always check for that first, though. Okay? Here's the next thing you do. You take A, which is 2, take A times C, which would be 6, and make 6 your new C value. Change A to 1. So when you do that, you'll get this. My new A value is 1, and you can see 2 times 3 is 6. Now, this should be pretty easy to factor. Factor it just the way you did in the past lesson. So let's think here. I know I got to have 2 negatives because I have a positive for C and a negative for B. Well, negative 6 times negative 7 is positive 6, and negative 6 plus negative 1 is negative 7. There's the correct factoring. Okay, now, here's the next step. We're not done. Since you started the problem by multiplying C by 2, you got to make up for it now. You got to divide both the negative 6 and the negative 1 by 2 and create fractions. So let me write that down here. I'm going to take negative 6 and divide by 2, and I'm going to take the negative 1 and divide by 2. Now, next, reduce each fraction fully. So let's think about that. 6 over 2, that's nice. 6 over 2 works out perfectly to 3. 1 over 2, I can't reduce. Okay, so I have x minus 3 for this first factor. Now, if the denominator isn't 1, okay, now over here I ended up with 3, but over here 1/2 doesn't reduce. You notice how the denominator isn't a 1? Take that denominator and move it in front of the first term of the binomial, and this would give you 2x minus 1. This is the correct answer. Now, if you look in the book and you look at that same practice problem, which I'm going to try to go back and get to, there's the answer. It's x minus 3, 2x minus 1, just like I got. Okay? The nice thing about this method that I'm showing you, this Brooklyn method, is it takes away a lot of the trial and error headache that your mom and dad or I would have had if A and C are bigger numbers. This could be a real headache trying to figure out the different factors. Let's do a few using that method. Let's factor this. Now you can see in the book the answer's here. Okay? Let's work it out with the Brooklyn method. So the first thing I would do is, do I have any common factors? And I always want to check that. No, I don't. Okay, take A times C. 3 times negative 5 is negative 15. So n squared plus 14n minus 15. Okay? Now, what times what's negative 15 and adds it to 14? Well, that should be pretty easy. Positive 15 times negative 1 is negative 15. Positive 15 plus negative 1 is 14. Okay? So I have n plus 15, n minus 1. Now I can't forget, I multiplied by 3 in the beginning of the problem. I got to divide by 3 now and reduce each fraction. 15 divided by 3 works out perfectly to 5, so that's n plus 5. And 1 divided by 3 doesn't reduce, so take 3, tuck it in front, and you get 3n minus 1. And you notice that's the exact answer that the book had. Pretty simple process to do that. Okay? What I'd like you to do is, why don't you try the next 3 problems, pause the video, and try the next 3. Okay, I'm back, and here's what you should have gotten for each of these. For number 1, when you use the Brooklyn method, you should have factored this into a t plus 2 and a 3t plus 2 factoring. For question 2, we should have a 4s minus 5, s minus 1 factoring. And for number 3, we should have ended up with an h plus 7, 2h minus 1 factoring. Now, if you aren't getting those, make a note in your notes that, hey, I need to ask this in class, and I would be happy to work through either or each of these if necessary to help you see it. Okay? All right, let's keep going. Factoring a problem like this. Now remember, if I go back a few slides, the first step of the Brooklyn method was to make sure A is positive and factor out any common factors. So going back, you notice A is not positive. So I have to factor negative 1 out of the trinomial. So let's do that. If I factor out the negative, you're going to get, you'll see it right here. Let me circle it. You'll see that if you factor the negative out, I'll have a positive 4x squared, a negative 12x, and a negative 7. So just keep that negative factor out front. Now let's use the Brooklyn method. If I take 4 times negative 7, I get negative 28, which is why you see what I have here. I keep that negative factored out. Okay, what times what's negative 28 and adds up to negative 12? Well, it'd be negative 14 and positive 2. All right, I can't forget, I multiplied by 4 in the beginning of the problem. I have to divide by 4, and I got to reduce. 14 over 4 is 7 halves, and 2 over 4 is a half. Go ahead, take the 2 in each case and tuck it in front. There's your answer. You'd have a negative, and then 2x minus 7, 2x plus 1, which is exactly what the book has. I just wrote mine in a reverse order. Okay, I have the 2x minus 7 in front and the 2x plus 1 after. But it's the same answer. So this method works great. It makes it a lot easier. It's a more direct method than you just randomly guessing and trial and erroring throughout the whole problem. Okay? Let's have you try. Pause the video. Now you notice, before I let you try, you notice how each of these have a lead coefficient that's negative. You cannot use the Brooklyn method with the negative in front. So first, factor out the negative. Don't forget to change the signs when you do, and work it from there. Pause and try. Okay, I'm back. So the first question, I showed my work here. You should be getting the opposite of 2y plus 3 times y plus 1. And for number 5, we should have been getting, for this, negative, and then m minus 1, 5m minus 1. And for number 6, we should have had the negative out front with x plus 1 times 3x minus 2. Now again, if you're like, wow, I'm not seeing that or I'm not getting that, make a little note and come to class. And when you come to class, say, hey, Mr. Lemansky, can we go over that question again from the video? I'm not seeing how you got to your response. And I can do it in class with you again, okay? Write and solve polynomial equations. And as you look at this, an athlete throws a discus from an initial height of 6 feet with an initial vertical velocity of 46 feet per second. Write an equation that gives the height of the discus as a function of the time. So that's the vertical motion model. So again, we have to know this model. And you notice the initial height is 6, so they plug that in for S. And the initial velocity is 46, and they plug that in for V. So there's your equation right here. Maybe I should have highlighted it. Let's highlight it. That'd be better. There's an equation that models the height of the discus at any time. After how many seconds does the discus hit the ground? That's part B. Well, let me think. The discus hits the ground when its height's back at 0. So you notice they went ahead and they wrote an equation. They replaced h with 0. I have to solve this. So first of all, I got to factor. You notice how the a value isn't 0. I got to use the Brooklyn method. So the first step, I definitely don't want a negative number in front, and I also want to pull out the greatest common factor. So I can definitely pull out the negative, but you notice all of these numbers are also even. I can divide out a 2 also. So if I factor out the negative and the 2, negative 16 divided by negative 2, that's where I'm getting 8t squared. Positive 46 divided by negative 2 is negative 23t, and 6 divided by negative 2 is negative 3. Okay? So now once I get to here, I see that I have a lead coefficient that's not 1, it's 8. So I'm going to use the Brooklyn method. I'll keep that negative 2 in front. I'm going to take 8 times the negative 3, and that's why I have the negative 24 now for C. Okay, what times what's negative 24 but adds up to negative 23? Well, that's pretty easy. Negative 24 times positive 1 is negative 24. Negative 24 plus 1 is negative 23 in the middle. I can't forget. Remember, I multiplied by 8 in that first Brooklyn step. I got to make up for it now. I got to divide each of these by 8, and I got to reduce these fractions. Now, I know 24 divided by 8 is 3. That's easy. 1 divided by 8 doesn't reduce, so I took the 8 and I tucked it in front of t. There is my equation, which is matching what they have here in the book. Now I got to solve. T minus 3 can equal 0, or 8t plus 1 could equal 0. Well, this is easy here. If I add 3 to each side, t has to equal 3, which is what I have here and what the book has. 8t plus 1 would equal 0. Well, if I take away 1 from each side, I get 8t equals negative 1, and then I can divide by 8. My second answer is t equals negative 1/8 seconds. Do you notice a negative solution does not make sense in this situation? We can't throw a discus and have it in the air a negative 1/8 of a second. So we're going to disregard that answer, which means we're just throwing it out. The answer should have been 3 seconds. So you're going to see the vertical motion model a lot in our word problems in this lesson also. So I think that's a pretty good synopsis of the Brooklyn method. If you didn't get these steps in your notes, I would definitely get these steps in your notes with maybe a sample problem next to it, like I had here, outlining what you're doing. Because this is a simple method that will get rid of the trial and error that your parents and I had to go through when we were factoring trinomials where the a value, the lead coefficient wasn't 1. I'm going to stop the video there. If you have questions, ask in class.